So Unit 5 was probability. A person flips a two-sided coin and rolls a six-sided number cube. How many different outcomes? You could list them all, or we have 2 outcomes here and 6 outcomes here. That will make for a total of 12 outcomes. All right, R is a person who likes to run, and B is a person who likes to bike. Who likes to ride and bike. It's going to be this intersection. Ride or bike is going to be everything in ride and everything in bike, including the intersection. Don't like to ride is going to be everything outside the ride circle. Who like to ride but not bike, so we can kind of this moon-shaped, the ride circle, but not including those that like to ride and bike. Okay, probability that a person likes basketball. I'm going to go to the total basketball, which is 80 out of the total number of people is 100. Probability the person is female, I'm going to go to the total females out of the total people. Hockey and is male, so hockey and male, so that's 14 people out of 100. Basketball and female, so here's basketball and female, so that's 24 out of 100. And then female or hockey. So you have 2 choices for part E. You could do the probability of female plus the probability of hockey minus the probability of female and hockey. Or you can add up the 6, the 14, and the 24. I'm going to do it the way I've written out in blue. So the female, that's 20 out of 100. Oh, nope, I'm reading it wrong, sorry. Female is 30 out of 100. Hockey is 20. Minus females and hockey is 6. And that gives us 44 out of 100. Okay, given that the person is male, means now my denominator, oh wait, sorry, I'm skipping F. Male or basketball. Okay, so I'm going to do total males plus total basketball minus male basketball. And they're all out of 100. So that's going to give me 94 out of 100. Okay, now for G, given that the person is male, meaning my denominator is now just the total number of males. So the person prefers hockey. So now if I'm just out of males, that numerator is going to be 14. Given the person prefers basketball, so the total basketball is the denominator of 80. And given that given that they prefer basketball, what's the probability the person is female? So there's our 24 for the numerator. Okay, for I, if the person is male and the person prefers to play hockey. So I can show that these are independent in 2 different ways. I can show that the probability of male, is that going to be equal to the probability of male given that they prefer hockey. You could also show probability of hockey, is that going to be equal to the probability of hockey given male. So let's just do the top red one so I have space to see my chart. Probability of male is 70 out of 100. And the probability of male given hockey, oh, which column's hockey? Hockey. All right, so the total hockey is 20. And the male given that is 14 out of 20. Now, it's hard to compare these fractions until you get a decimal, so 70 out of 100 is 0.7, and 14 out of 20 is 0.7. They are equal, so therefore, male, a person is male and a person prefers hockey are independent. Okay, so in 31, they labeled the Venn diagram for us. Probability person eats fruit. So that would be the 42% plus the 8%, or 50%. Does not eat vegetables. So I'm going to take the fruit only plus the no fruits or vegetables and add those up and get 60%. Eats fruits and vegetables is the intersection, so that's the 8% in the middle. Eats fruits or vegetables, so since it's an or, we can do the 42% plus the 32% plus the 8% and get 82%. Okay, given that the person eats fruit, so that means my denominator is 42 plus 8, which is 50. Also eats vegetables, so that's 8 out of 50. We can divide that and get 16%. Given that the person eats vegetables, so that's the 32 plus 8 as a denominator. Also eats fruit, so that's a numerator of the intersection, and 8 out of 40 is 20%. Does not eat vegetables and also does not eat fruit. So that would be the outside percent of 18%. Okay, so for 32, if the probability he works overtime on any given day is 40%, and we want to know if he works overtime on 3 consecutive days, we're going to do 40% times 40% times 40%. And that is 0.064. And then for 33, because they're independent, we can multiply the probabilities. And then for 34, all 3 are peach. All right, what's the total? It's 4 plus 2 plus 5. It's 11. So there's 5 out of 11 peach to start. And then there'll be 4 out of 10. And then there'll be 3 out of 9. So when we multiply, we get 60 out of 990.